Welcome to JDesigner Tutorial 4, Modeling True Bistable Systems. Bistable switches are commonly found as network motifs in prokaryotes and sometimes in eukaryotes. They represent the biochemical equivalent of a light toggle switch. In this tutorial, we will introduce a bistable model and illustrate its unique switching properties, as well as introducing the notion of a free format rate law. We will now enter our model into JDesigner. The model represents a simple regulatory loop from S1 to V1. The regulation is positive in the sense that when the concentration of S1 increases, the rate through V1 increases. The problem, however, is that there is not a built-in rate law with this property. Instead, JDesigner permits one to enter a free format rate law. To begin, drop down 3 species nodes. Change the properties of the first one by renaming it X0 and making it a fixed boundary species. Rename node 1 S1. Then, rename node 2 X2 and make it a fixed boundary species. Then, add uni-uni reactions between X0 and S1 and between S1 and X1. Right-click over the first reaction to bring up the Reaction Properties panel and select the tab marked Free Format. At the edit box containing J0 KX0, type in the following expression: 10 plus X0 times 3.2 times the quantity S1 over 0.75 to the 3.2 divided by quantity 1 plus quantity S1 over 4.3 to the 3.2. S1 acts as an activator, stimulating its own production. Then, hit the Tab key to move focus. Next, select the second reaction, this time choosing an irreversible mass action rate law with rate constant of 12. Set the concentration of X0 to 0.12 units. Set the initial concentration of S1 to 0.1. Next, close any open windows and open the graph panel and a time course panel. Set the time end to 1 unit and run a simulation. Notice that the system approaches a steady state with a value of roughly 1, nothing out of the ordinary. Let us now change the initial concentration of S1 to 4 and carry out the same simulation. You will also need to change the axis limits by right-clicking over the y-axis and setting the lower limit to 0 and the upper limit to 10. What is unusual is that the model has clearly settled to a different steady state, a high steady state compared to the first run. You can return the initial condition of S1 back to 0.1 and run it again, and you will see that the system settles to the lower steady state. This model appears to have 2 quite different steady states for the same set of parameter values. This concludes Tutorial 4. In Tutorial 5, we will investigate a well-known oscillator called the brusselator.